So next I would like to introduce Dr. Pathak. He is a UCANR specialist focusing on climate issues and adaptations in agriculture. So welcome, Tapan.
Okay.
Go ahead.
Thank you for having me. Can you see the slides?
Yes, we can.
Okay. All right. Okay. Thank you for having me. My name is Stefan Patrick. I'm a cooperative extension specialist here at the University of California in Merced, and I'm also with the UC Ag and Natural Resources. My work is mostly focused on climate adaptation and agriculture. And today I'm going to talk more broadly about what climate change means for California agriculture and what sort of trends and impacts that we are seeing in California and how it is impacting agriculture. So this is just a brief outline. So first half of my talk is mostly going to be what we have observed in the past and what we might expect in the future in terms of trends in different variables such as temperature, precipitation, extremes, snowpacks, etc. And the second half is more specifically how those trends are going to impact agriculture in many ways. And the last slide is more broadly about what sort of research directions, and that is not a comprehensive slide, but it's just something that one of those many research directions that we need to think about. Okay, so and this slide is probably not new to this group, but I just wanted to show how the scale of agriculture in California and how huge it is. So we have 76,400 farms, and that number varies from year to year. And it's the farm gate value is 46 billion, although the impact is much broader than that. But this is the CDFA numbers, and that do vary year to year. Out of those 100 million some acres of land, only about 9 million acres is irrigated agriculture, and we produce 2/3 of the fruit production and 1/3 of the vegetable production for the entire country. And so that's a big scale industry. And when we think about Southern California or the coastal region, that is a predominant tropical fruit production region for the state, and that is pretty unique for the whole country. If you think about top 10 crops, so that includes dairy, grapes, almond, cattle, pistachios, strawberries, lettuce, floriculture, tomatoes, and oranges, and some of them are part of the Southern California production system as well. Okay, so moving into changes. So first, let's talk about temperature trends in California. This slide shows how temperature is varied in California, in different parts of California in last 100 or so years. If you focus on the Central Valley, which is a combination of Sacramento Delta Valley and the San Joaquin Valley, and as you can see, the rate of increase in the minimum temperatures are substantially higher than the maximum temperatures. And that trend is almost consistent across different climate zones. South Coast, for example, experienced the most increase in the minimum temperatures at the range of 3.5 degrees Fahrenheit for the last century, for the last 100 years, and relatively lower rate of increase in the maximum temperatures. The same with the Sierra Nevada region. The minimum temperatures are substantially higher than the maximum temperatures in terms of how they rose in last 100 years. And there are a lot of consequences related to that, and I'll touch on some of those consequences of minimum temperature increases in California in agriculture. So when we think about precipitation, in this slide I have two Northern California, one Southern California location in terms of how precipitation has changed in the past and how it is expected to change in the future. As you can see, we see a lot of variability, but almost no trend. And so not in the historical side, not on the projections, and both in the low and high emission scenario. But what this slide is telling us is that we might expect more and more variability in both extremes, dry and hot, dry and wet extremes. And then we have to be ready for those kind of extremes, and how can we adapt to those situations. I think that is going to be crucial. Another important fact about precipitation trends under climate change is that although there is less skills in terms of the precipitation trend, but there is more confidence from climate modeling perspectives in knowing that the overall wet season for California is shrinking. So even if we get more rain, those rain is going to be in few but extreme single day precipitation type events in the future. And so that can cause more flooding type situations. So if we classify both temperature and precipitation and put them in these four different categories: dry hot, dry cold, and wet cold. So most of the recent years are either in the dry hot or wet hot category. So in general, we are hotter than normal. But more specifically, last 15 out of those last 15 or 20 years or so, many of those years are in, especially in the dry and hot category. And so we had this exceptional drought recently in California, and many of those years are part of this dry and hot category. So we can expect both dry and hot and wet and hot category in the future as well. And this is based on the historical records. Okay, so in terms of extreme heat days, I pulled this from CalAdapt, which is an online tool where you can pull some of those projections very easily and look at for different locations. So I pulled this one for San Diego, and what it's telling us is that these extreme heat days are defined as a 98th percentile of the range that we are choosing. So for example, in this 1980 to 2005 range, the temperature threshold for San Diego was 89 degrees Fahrenheit. So we experienced 4 days when temperature exceeded it. This is on an average. So 4 days where temperature exceeded 89 degrees. And when we take this and put them in a projections mode under high emission scenario, in the future, between 2017 to 2099, we can expect 3 weeks where temperature exceeds 89 degrees on an average. And not just that, when we think about timing of those extreme heat days, most of those historic years, you see scattered dots, which shows that there are only a few years where we got extreme heat days happening in the past. But as we progress into the future, it gets denser during the summertime. But another important fact is that the extreme heat events start as soon as April and last as long as October and November. And so there is a lot of issues, not just related to agricultural productivity, but farm worker health as well, and the other consequences related to that. Another slide related to heat event is especially when you think about agriculture, the extreme heat events, and especially if you have those extremes for not just 1 day, but consecutively for 3 or 4 days, that has more damage to agriculture than extreme heat events happening just once. And so number of 4-day heat wave type events in the past, on an average, it was roughly 1 or 2, those kind of events happening. But in the future, we might expect 3 or even 8 or 9 in some years, where you have heat waves happening where temperature exceeding that threshold for more than four days or so. Snowpack, which is our natural water storage for California, And as we can expect from minimum temperature increases and the wintertime temperatures, we are going to see less and less snowpack in the future. So this is from one of the Department of Water Resources publication. Under low emission scenario, we can expect 48% loss in the snowpack by between 2070 and 2099. And under high emission scenario, it's even worse. It's 65% loss. And there is another estimation by DWR is by 2050, this expected snowpack loss could be around 25%, which is significant snowpack loss in California. Okay, so we talked about changes in temperature, precipitation, some of those extremes, and snowpack, etc. Now let's talk about what are the potential impacts on California agriculture. So a couple of years ago, we published this review paper, which is a pretty comprehensive study on trends and impacts on California agriculture. And this is an open access paper. So I just wanted to show this to, if you want to access this paper and get more details about the trends and how it is impacting agriculture. I suggest that you download that and review it if you like. Okay, so if we talk about impacts on yield, so one thing I want to mention is California, we have a lot of specialty crops, and we don't have process-based models for all the crops, and to sort of quantify types of impacts on climate change on different crops. But this is one of those studies where they looked at some of those important crops. And as you can see, under future climate, both low and high emission scenario, there is almost no impact on alfalfa production, as you can see on the first top left corner. And but if we focus on, let's say, rice, wheat, cotton, and sunflower, you start seeing negative impacts due to temperature increases. So again, this is a modeling study. In this one, and this I pulled from one of the publications, which was also part of the National Climate Assessment Report. So one important thing is that they haven't looked at the water stress situations in this. So it's under the well water situation, and it's only looking at the temperature stress. And so when we think about the future of California, water is going to be a big issue. And so how water stress might change some of those yield numbers is another interesting thing to look at. And another important thing is that they haven't looked at any adaptation measures, and so that brings a potential of adaptation is pretty important in agriculture for climate change. Chill accumulation. So as you might be aware, some of those specialty crops, some of the stone fruits and nut crops, they do require certain amount of chill during the winter time to break their dormancy and have a proper bloom in spring. And there are many ways in which they are accumulating chill. There are chill hour measurement, and there's more dynamic chill portions. And on an average, we can expect 20 to 30% reduction in amount of chill received by. So if there are crops that do require really high number of chill accumulations, those type of crops are definitely going to be vulnerable under future climate. So length of the growing season, that is a time from last spring freeze to first fall freeze. So the entire time frame is expanding. That's a freeze-free time is expanding in general for the entire U.S., but more specifically in California too. So if you compare Western U.S. in general, you might expect 15 days more freeze-free time, additional freeze-free time. Whereas in California, that number is more than 3 weeks or so. So that, not to confuse that with the time from emergence to maturity. So we did this study in 2018 on processing tomatoes for 5 major processing tomato producing counties in California in the Central Valley, what we found is that with this temperature increases, some of those annual crops can reach those different growth stages faster because they accumulate those heat units much more faster than before. And so in the future, under both low and high emission scenarios, we can expect those tomatoes maturing significantly earlier than they used to be in the past. And so that number varies with respect to different counties, but in general, we can expect 2 to 3 weeks earlier maturity in some of those crops. And another agronomic factor that we did not look at in that study is that when you have this time frame shrinking, that might also impact yield. That's something we didn't look at in that study, but there's another potential consequences. So this is an ongoing study where a colleague from UC Davis, Lauren Parker, is leading this effort to quantify how much reduction we might expect in terms of the frost risk for many California counties. And in this one, I'm showing for 2 counties, Ventura and San Diego. And as you can see, in the future, we might expect much less snow, much less frost risk in many parts. And so that can open up a lot of regions where frost was an issue in the past, but not anymore. And that brings additional opportunity for agriculture in some areas. And again, that is also tied to the minimum temperature increases that I was referring to in my initial slides. Okay, so along with that, another potential impact of temperature increases is going to be on weeds and pests and diseases. So we just published, not published, we just submitted a study where a colleague of mine, Jalendra, who's an IPM advisor in Central Valley, and another colleague, Mahesh, and we looked at how climate change might alter cycle for navel orange worm, which is one of the major pests for walnut, almond, and pistachio in the valley. And what we found is that we might expect one whole additional generation of navel orange worm in most of the counties in the Central Valley in the future, and that can add a lot of significant yield risk for many crops. And apart from that, we might see decline in the production, which is tied to those pest and disease and weed pressure. We saw that frost risk is reducing, and so that might alleviate some of those, the pests which are frost sensitive, and that can add more pressure into the spring and the growing season into summer. Increased rate of development and potential northward migration of pests, and with this additional temperature and CO2 increase, then it can increase the weed biomass, which can compete with the production agriculture. So this is my last slide, I believe, or the second last. So we are just getting started on this project. It's called CalAgroClimate, in which we are trying to integrate historical and future weather and climate information and put them in a decision support perspective for that are, and those tools we are going to be targeting to be crop specific, region specific, and location specific. And so some of those example of tools that we are trying to develop is heat advisory system, frost advisory system, growing degree based phenology and pest detection, and many other agroclimatic indicators. And we try to make it easy for growers and ag community to use it. And so we are going to be taking a lot of growers' advice on how to make it grower friendly and tailored to their needs. So we'll have more updates on that in the future. This project is funded by USDA, and myself and Steve Ostoya is leading this effort. Okay, so in last there, although as I said, there are a lot of other potential research needs, but from my experience, I think we need to do a better job understanding how those extremes are going to be impacting different crops, and we really need to quantify that. Another thing is that we are using models a lot for quantifying those impacts, but sometimes models are not ready. So we need to do a better job and getting those models ready and parameterize them to be used for climate change impact studies. And we need really crop specific, region specific information and put them in our decision support, which is something we are just getting started on. And the last point is really important, that providing only this facts is not important. We have to work with stakeholders to make California agriculture more resilient to those climate and weather risks. With that, I'll stop. Thank you so much.